Hello everyone, how are you? Hope you all are doing well. I have given all of you a homework. How many of you have done it? Can you please hand raise? Ashutosh, okay, great. Anybody else? Vidyashri done. What about everyone else? Okay, Vidyashri, you can tell me. I have unmuted you. What you have done? Please share something. Shivam also has done it. Shivam, you can also unmute yourself and tell me. Yes, what you
Yes,
have
sir.
done, tell me.
Sir, I was supposed to study the differences between different types of bracing in the steel frame.
Hmm.
So basically, we have a concentric bracing, eccentric bracing, and we have a moment resisting frame. In
Okay,
concentric bracing frames, we have bracings or kind of truss which connects both two ends of a building or a structure. So both the ends of the brace will join at the endpoint of the other framing member. But in eccentric bracing, we have only it will be connected to one, or maybe it can be connected to both the sides of the framing members. In
hmm,
in bracing, we have pin joints between the members, and in moment resisting frame, we have rigid joints. So in a moment resisting frame, when there is a lateral load exerted on any of the structure, so the load is transferred using that joints in and the moment is transferred to the foundation, but there is no
okay,
transfer of moment in bracing frames.
okay. So, I'll give you an example. They are like to have told us that bracing are there. See, in bracing or any other, there is a type of joints. Okay, there are shear force joint or there are moment resisting joints. So this is the main difference of rear bracing. Bracing, if it is welded, it is not shear or shear force resistance it will provide. But once you have bolting, it will provide you the some tolerance in which you can move your building. So that is moment resistance. Okay, I'll give an example. I'll open an file. This is an your class book. SS Bhavikati is a very famous book from which we have taken these examples. Movement joints. So can you see this? This is your movement joint. Bracing mostly are done with the help of you can say plates. So in this any if the movement is there in this beam, there is no problem because these bolting will allow the movement to move. But once I have done the you can say welding of these joints, it will be like a totally resisted joint. Apart from that, there is an option called concentric and eccentric bracing. Concentric bracing is, you can say, these, where the line of actions of both the things come at a particular point. Can you see this? This point, this point. Eccentric bracing happens when it is like this. When the line of action is different, it is mainly used when you see a tower sometimes. There's a question. I think there is problem. Vivekanand, can you see my screen? Okay, just a moment. Are you able to see my screen now, Vivekanand? Okay, great. Okay, so for an example, this is concentric bracing in which the center line of action will comes. This is eccentric bracing. What will happen? when we do some bracing, see STAAD Pro, it work in the center line action. This is your bracing. What will happen? Suppose this is your brace joint. So you can see in this a particular point the line of action which I colored in red color. It is like this. The line of action is same, but in usually this is not the scenario. The line of action totally differ. How it will differ? It don't joint at this place. It will joint at this place with the help of plates also. It will be like have a plate like this. Most of you have seen it like this. You will have a plate, and these are joint at this place, not at till top. So if you see the line of action of both, it will attack at this place and this place. This is eccentric bracing. Okay, like some frame movement resistance will provided with a special kind of joints. Those are movement adjusting frames. Like dampers are movement adjusting frames. If you provide dampers, it will resist a movement. What kind of a movement? Seismic movements. I will show you the seismic dampers.
What's for our Daily Planet today? Select, tap, and
You don't have a safe building, you don't have a building. When an earthquake happens, the ground is moving and it has all these waves, and the ground can be shaking in any direction.
See this.
So we have to make sure the system that we have can take the forces hitting it from any direction.
This is the deck slab what they are creating.
Ability to ride with the waves of the earthquake and have the building remain intact.
There's no scientific way to predict whether the earthquake is going to. However, based on what the scientists tell us, California is due for a big
Generally, the most traffic failure.
That's what the most challenging part about it.
See these are the dampers.
Here.
What will happen when the earthquake comes now? It is not, this video is not good. This will, I think, work fine. Can you see this? Now everyone has seen this. Now how this will work? Those who understand it, just raise hands. Okay. Now the dampers concept we have to understand. Dampers work on a liquid concept. Okay. From a hole, a liquid will pass from one part of damper to another part of damper, which will provide the resistance or transfer the movement or transfer the force, okay, into another action. So I will give you the example. See, I have done some parts of my graduation, some parts in mechanical projects also, so I have a great idea. This is how a bike damper will work. Shock absorber or damper, these are also called dampers. It is not that these are something else. These dampers or those dampers which we are like using in our building, these are pretty same. You see this, how the shock has been absorbed.
It is also available, known as the monotube shock absorber. The monotube shock absorber, as the name suggests, has only one tube. This tube has two compartments separated by a floating piston. The first is the working chamber where the oil is located and the rod is moved.
See, they are telling there is a first chamber where the oil is there. In our earthquake dampers, there is some solution, oily and silicon solution.
The first is the working chamber where the oil is located and the rod is moved by a combined twin compression rebound pump. Expansion chamber guards with high pressure nitrogen gas between 25 and 30 bar, which, backed with retraction and rebound effect, keeps the working chamber constantly filled with oil. The floating piston made of metal or sintered plastic material, which separates the gas from the oil. Shock absorber is compressed. The rod enters the working chamber and the oil compresses the gas, causing the floating piston to move, reducing the volume of the chamber. By contrast, when the shock absorber is extended, the rod leaves the working chamber, reducing the gas pressure, which causes piston movement, ensures that the working chamber is constantly filled with pressure. The high pressure gas chamber is controlled.
I think all of you must have understood this.
So,
I'll show you one more video. Mm, Not much is explained.
Type of sign is scared. A bill sign is professional off-road racers. Off-road racing places unusually severe demands on shock. Our cycle will quickly through the shock absorber. You'll see that it cavitates immediately. Starts to lose its control, its viscosity, and basically all the functions the shock absorber was designed for.
Can you see this? A piston is moving between the oil. We have some holes in this piston so that oil can flow from one part of chamber to another part. This will create the like a transfer of your pressure or your movement into another energy. That is energy in movement, or you can say heat also.
And you can see immediately a lot of cavitation is removed from the oil column. Efficiency from Bilstein shock absorber for a lifetime of its use. There are also original equipment.
So these have been done. Okay, in cars we are working on this a lot from so many years, but in buildings now we have come up with these damper sets. Now after doing all of this, now the basic concept come up ki, you have done this, but we have done yesterday only dynamic analysis of seismic. So now what we are going to do, I'm going to tell you about the response spectrum analysis, which is dynamic analysis. Previously yesterday we have done static. So for dynamic analysis, we'll again go back to a new project, create some project name. For the dynamic process, it is not necessary to define the seismic load first in my building. I can define it afterwards also. I will just define any small building with some reference. Simple, same magnitude of building I have taken with same length and width on all those details. Just a moment. I'm having So what we'll do, we'll follow the same building with same loads, but the definition will be also same. I'll go to general load in definition. I'll just define my definition of seismic load first. Add. As per my codes, as I have told you earlier, I have memorized these things a bit. Okay, these things you can do it from generate, because my generate is not working. That's why I'm putting these values. I know these values. I have told you yesterday. I'll go to add. Okay, factor sulfate. I'll put it 1. Member weight. You can say UDL. UNI means UDL. I'll put it 13. There is no minus sign in here. I'm giving. Add. After adding all these, what I'm going to do, I'm going to assign only UDL, which is needed for right now. Now I'll define the load. Before defining the loads, what I'll do, I'll just go to my properties and add the property of like 300 mm by 300 mm for my building columns and beams. 0.3 by 0.3. This simple as we used to follow in previous classes. I'll go to add and assign to my whole view. Okay, after this, there is one more important thing, supports. Now I'll go back to load and cases again. Now in previous class, I have told you have to define the seismic load first in any cases. But in response spectrum, this is not the case. In response spectrum, this is a dynamic analysis. You can define it afterwards also. So for first, I'll define dead load. Then I'll define live load. And I'll then define seismic load. On the basis of 3 loads, we are going to provide the loading on my building. So I'll go for first, which is dead load. Self weight is a very common thing. Then there is a wall load, which is minus 13 as per the definition of, you can say, my IS code. Now just a moment. Hello. Okay, so I'll add these with global directions. These steps are like same as what we have done in previous classes. Now after adding loads, I'll go to my live load. Live load only I'm going to define my floor load right now, which is minus 2.5 as I have defined in earlier in my seismic zones. Now the basic important thing what we are going to put it in response spectrum is the response spectrum command. I'll go to my seismic load definition. I'll go to add. In your add definitions, you have one option called, in these loads you have one option called response spectrum. So in this response spectrum, if you want to understand how this will work, you have to go to again your codes. Okay, So I will tell you the clauses in which you have to found. You go to response spectrum. In this there is a custom like a notation and all those inputs you values you have to do. So first value is your code. Always select your IS 1893 because as per your Indian code. Second is your combination method. Okay, according to our Indian code, some combination method are we are using. We can use any combination method, ABS or CQC. I think Ankita, which combination method we use? Tell me. Ankita, you can unmute yourself. Which combination method we are using for seismic load analysis in India? I think she is unable to speak. Vidyashri, Raj Rajeshwari, Priyadarshan. Those who know, just raise hand. But my computer will tell the combination in ABS CQC according to my codes. So I can select anyone. So let's keep it SRS. Now what you have to do, you have to go to your IS code. In this IS code, I have yesterday told you that about the value of QIK. Actually, we have to find out the value of QIK according to our formula in IS codes. But this QIK will be automatically, which is the base share value for the different columns, will be automatically calculated by my software. So for defining those, what I need some values like VB upon B, which is in clause 7.8.2. Okay, then there is a AH value which is 7.8.4.2. And I go, there is some values you have to consider or the formulas. QIK formula I have told you yesterday. This design lateral force on 4I in mode K. Okay, this is QIK, what we have to find it out. So then SA by G is average response acceleration coefficient for rock or soil. This will be done here. Once you provide the soil class, hard soil, medium, it will automatically take it acceleration. Okay, or you can do the custom acceleration. You can see the period and along the acceleration. Okay, then we have value of AH. We have value of AH. AH design horizontal seismic coefficient. AH, the formula for AH, you can find it in clause number 7.8.4.2, which is ZI by 2R. If I go down, this ZI by 2R, ZI by 2R is the AH. SA by G will be automatically used along with this, where I is the importance factor, Z is the zonal factor, and R is the response reduction factor. Okay, these things you will be needed. So what you have to do in this seismic analysis, you have to just select your method of combination, your soil type. I'm taking medium soil type right now. Then mode shape. Do you want to ignore the mode shape which are beyond it? The mode shape definitions in code, there is an option in which it is provided the mode shape. What we are going to use is always with more than 90% of the participation factor. Now, can anybody can explain me what is the participation factor? Just raise hand if you know it. Nobody knows participation factor. Guys, you haven't like read these codes. Uh, I forget where is the mode shape details. PK, mode participation factor of mode K. I forget the place where the participation factor is there. there is a clause in my IES code that participation factor for the mode should be greater than 90% or 80%. It is there. Just find it if you find the participation factor. See guys, I'm teaching you along with the code so that you can understand how to read these codes. This is also important. T equals to 0.09 upon D, which is a time duration for your wave. Then VB, which is design seismic base shear, VB equals to AH into WI. AH value will find it. WI we have already put it, which is the weight, seismic weight of a building. Okay, we are going to. Okay, this is the mode to be considered. The number of mode to be considered in the analysis should be such that. Okay, who can read this? Uh, Prerna. Prerna, unmute yourself and read this 7.8.4.2. Clause number as per IA 1893, part 1, 7.8.3.2, mode to be considered. Prerna, read this.
Modes to be considered. The number of modes to be used in the analysis should be such that the sum total of model masses of all modes considered at least 90% of the total seismic mass and missing mass correction beyond 33%. If modes with natural frequency beyond 33 Hz are to be considered, modal combination shall be carried out only for modes up to 33 Hz. The effect of higher mode shall be included by considering missing mass correction following well-established procedures.
Very nice. Now who can explain this? Satyendra? Acha, raise hand who understand this. I'll tell them to explain it. Just raise hands if you know what it clause is saying. No one. Okay, this clause is saying that the modes of vibration, only those vibration will be considered in which the model mass, okay, which is the WI, is around 90%. Means अगर मैं किसी चीज में एनालिसिस कर रहा हूँ या पार्टिसिपेशन दे रहा हूँ, सपोज आई एम गिविंग यू training, my participation is 50% because another 50% will be from your side. If you will not perform, there is no use of teaching. So if you are also performing, I am also performing, and the both participation from the both sides is around 90%, then we will only consider that. So in this clause, it is telling that if the mode shape or the participation of these modes will be beyond 90% or above 90%, then only we'll consider these modes. Okay, just a moment. I'm having so many calls today. Okay, so those modes or vibration, you can say the modes are like a vibration. You can estimate those vibration in which the participation of building or a model mass or a building mass is beyond 90%. We will consider that only for the seismic calculation. So suppose I will give an example. Suppose this is my building. This is my building. A load or a wave come from this side. What will happen? This building will vibrate. Like in the video I have shown you, a few minutes back. Dampers. There's a video of there's a video I have showed you in seismic dampers when there are small, they have like move a small model. So suppose you can say in first wave, when the first wave of man pushes, not the whole building has been performing well, okay, or neither it's have contributed to the movement, okay, which is called momentum. Momentum is mass into velocity. The whole mass is not contributing, or when it will move from this, okay, when it will start vibrating. See, in first wave only first few like floors will move. Once it increase the intensity, all of the buildings start moving in a synchronized way, like this one, like this one, okay. So this is when we consider those modes only where the building mass is contributing to the movement with 90% of its weight. So for that we include 90% according to as per our code. Now, in which direction you have to take your time period? Okay, in this directions, what you have to put in this damping ratio, you have to put 5% is a damping ratio. In this, you have to put the value of a Zi by 2r. What is Zi by 2r? According to x and z, if I put calculate the Zi by 2r, which is ah, Zi by 2r will be z will be your zone factor, which is 0.36. Okay, this factor, removing the SA by G, we have to multiply AH equals to Z by 2R. So Z is 0.36 into I is 1 upon 2 is your numerical formula, and R is response reduction, which is 5. So it is 0.36 divided by 10. So value come up with 0.036. So we'll put the value of 0.036 in this and here also. And then what we have to do, we have to add it. After adding these all these details, what we have to do, we have to create a combination. Suppose we'll create only one combination of 1.5 and add all of them. And add only one combination I'm creating and doing the analysis right now. I'll add my analysis, no print, close, add analysis, save. Okay, now I'm having two errors. I'll see those errors. What are these errors? Okay, mass defined under loads 3 will form a final mass matrix. For dynamic, no unsupported masses entered. Check that densities. Okay. Okay, guys, I think let's do it again in another file. We'll close this and open the yesterday's file and do the response spectrum analysis. Response spectrum analysis in this. There is some error in our recent file. I don't know what it is happening. I have to check it from the start with the coding file. So I'll go to my yesterday's model, load in definitions. I already have X and Z loads. Instead of that, what I'll do, I delete those. Z also I delete. And instead of these, I'll add response spectrum. I think, guys, there is some error with my I think current software. I'll open the advanced one and then do the same. You have to wait for 2 more minutes. Okay, so this is a basic procedure. There is one more thing that I have to show you in this. Oh, sorry guys, I forget a one step, a very big step. There is an error called where unsupported mass is coming. Okay, what do you mean by unsupported mass? There is an option called in our formula QIK, which is about WI. In our QIK formula, there is an option which is coming that you haven't defined a mass. There is an which is WI, and if you see what is WI, you will understand it is a seismic weight of a building. This seismic weight of a building on a floor. I haven't defined this. Okay, to define this, what you have to do in seismic load only or in response spectrum only. I forgot this step. In your response spectrum analysis only, before defining the response spectrum, once delete it, what you have to do it, you go to your response spectrum, add in seismic load, you have to add self weight in all the three directions, keeping this as 1 to define the WI. Okay, along with that you can add member weight also or floor load also. I'll define member weight of 13 in global X, global Y, and global Z. Along with this, I have to define the floor weight also. This is a very big step that I forgot. 2.5 kilonewton with 20 meters. Y in global X, global Y, and global Z. Okay, I am doing this only to define the seismic mass of a building, which is called WI in this. This WI. Seismic weight I have already defined of a structure. Seismic weight I have already defined in my definition here. But for WI, I have to define it for all these loads again in all the directions. Then only we can do the seismic analysis for the response spectrum. Now I have to add it to my view. Now I will define the seismic direction. Okay, seismic load for the response spectrum. I'll go to add, go to response spectrum, define all those things again. That is the only like step I forgot. That is a very big step. 0.036 and 0.036. Okay, now I'll go to add, close, and now if I do the analysis, it will run. Again, the error is there. I'll see. Above command is not recognized in line. Command check spelling or order in the data case number. Check data in case number 3, soil type. Okay, I think guys, I will check this once more and then let you know tomorrow. We'll do the same class again tomorrow for the response spectrum. The procedure is same. I'm unable to find the error. I have to find it in my coding file if some error is there, because sometimes I have to read some coding file also. The steps I am following, sometimes these are not in sequence also, then the error will come. I have to check my coding file once and then I'll get back to you. Okay, till then, those who have understand the rest of the classes, it is good. Those who don't have understand it, will again continue with the same topic tomorrow, and then we'll do work with design from next week. If you have any doubt, just raise hand. If you want to ask anything, you can raise hand now. Okay, last. Akshay, any doubt? Akshay, Ankita, Ashutosh, Rukesh, Kangalakshmi, Prerna, Priyadarshan, Rajrajeshwari, Shivam, Varsha, Shubhankar, Vivekanand. Any doubt? Any one of you? Okay. If nobody have any doubt, then we'll continue tomorrow with response spectrum once again, and then we'll continue the design next week. Okay. Till then, stay safe. Have a nice day. Bye, everyone.